All right, good morning. What better way to start off the day than with a glass of water and advent of code? All right, so in this video, I'm going to be doing advent of code day 3, 2020. So, yeah, before we get started though, I just want to say I have a Twitch channel. It's at twitch.tv/robogenes. On there, I stream some chess games occasionally, basically once a week on average, maybe more. It's pretty inconsistent though. So please check it out. The link is in the description. Okay, so let's get started with day 3. I'm gonna solve the problems. You're not gonna see me solve the problems though. Like it'd be great if I could do a time lapse, but I'm too lazy to edit, so you're just gonna see some cuts. Okay, so day 3, toboggan. Day 3, toboggan trajectory. With the toboggan login problem solved, you set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering, and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. How convenient. You make a map, which is your puzzle input, of the open squares and trees you can see. For example, these aren't the only trees forever. However, due to something you read once about involving arboreal genetics and biome stability, the same pattern repeats to the right many times. You start on the open square in the top left corner and need to reach the bottom below the bottommost row on the map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3, down 1. Okay, so they explained it in more detail. Okay. Fabulous. Okay, this can't be too hard. I've actually looked at the problems the previous day, so it should be a lot easier. Okay, I'm going to solve the problems. I'm going to come back, and then I'm going to explain them. Okay, so great. Okay, so we have arrived at one answer, and our answer is 176. So perhaps that is correct. Okay, that is correct. Okay, I keep getting these first try. I'm going to jinx it though. Okay, so time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if for each of the following slopes. Okay, so we're given a list of slopes. The slopes would find, okay, multiply the number of trees countered on. Okay, so this is pretty simple. I think all we need to do is turn this into a function. So, like def count trees or something. I might just do this live. So, slope, and then slope is going to be like y direction and x direction. So this should be, okay, actually we're going to do a y slope, x slope. That might make it a bit easier. So this is going to be x slope, and this is going to be y slope. Okay, fantastic. And then we just have, okay, I'm actually going to cut here, so. Okay, I keep forgetting to turn this into part 2. But okay, we got this covered. So, oh, actually, you know what we could do? We could just say prod equals 1, and then just do prod times equals. Okay, so we got this big number here. Let's see if it works. I don't think it's gonna work. Oh, it works. Okay. Okay, so I guess it's now time to explain the problems. And it looks like it's forming some kind of tree here. We can say that for previous years, it made different shapes. So this was like a solar system. Actually, I have no idea what this was. What this is. I think it's some kind of computer thing. Oh, wait, no, this is a computer one. And then, oh, this is like a city. Okay, so I don't know what this is going to be. But, okay, so I'm going to explain the problems now. So, for problem 1, actually for both problems, this is kind of like a simulation problem. So, basically we're given a map, and then we have to simulate going right some number of steps, and then down some number of steps. For part 1, it's just going right 3 steps and down 1 step. And we have to repeat this until we're done, and then on the way we just count how many of these pound signs we encounter, or hashtags. So this is really a simulation problem, if we get our input, we can read that as a text file, and then we can separate into different rows, and each row just represents like one y coordinate, and then we can turn that into an array, and then using that we can just access it using what we can see over here. We can access a position on the map using a specific row and a column, and basically we keep track of our position, and then we just do a while loop, and then we just increments our x position and y position, and yeah, and then we just keep track of how many hashtags there are, and then we just keep going until we hit the bottom, and after that we're done. So yeah, for part 2 it's essentially the same thing, except we turn it into a function instead of just hard coding the numbers in, and then with the function we also just get a list of the slopes that we are given, and then we just multiply them together. So it's a pretty simple problem. It's just simulation. I forgot to explain the looping part. If you are on the right of the map, you can actually just kind of loop over, because the coordinate that's on the left side of the map is the same that's directly to the right side of the map. So you can essentially pretend that you're looping over the map every time you hit the right edge or you go past the right edge, and that's what this modulo operator is for. You just take your position modulo width, and that gives you a coordinate that has the same value as another place on the map, because the map is cyclic, so you can pretend it loops. I think that's all there is to explain. Let's see how long this recording is. Okay, it's only 7 minutes. I want to keep these videos relatively short, so I think that's going to be the end of day 3. I think like in the future, I'm scared that they're going to do some kind of like something later on where you have to like find the optimal route or something. That's going to be pretty scary, but it's not going to be too hard. That's just some like flood fill, DFS, BFS, maybe. Yeah, I don't think they're going to do anything that requires any algorithms though. So all right, so thanks for watching this explanation. Hopefully it was clear. If you have any feedback, please leave them down in the description. Please leave them down in the comments, because I'm going to do a lot of these videos. There's going to be lots of opportunities to improve, so please let me know any feedback. And just a reminder, I have a Twitch channel, twitch.tv/romogenes. Link is in the description. Please check it out. And also I have a playlist of the advent of code, I guess like tutorials or solutions videos. I'll link that playlist down in the description as well. So yeah, thanks for watching. Hope it was clear, and I will see you tomorrow with day 4.